next presentation is the spy rotor.
Good afternoon, all present. I'm going to present about the spy rotor group. You have a question? I'm going to present about the spy rotor group, starting from my team members, starting from the right over there. It's Thursday, Simon, Richardson, Mark, and Kinay. We did this topic because we've seen a lot of these devices come into play where people have been using them as their toys, helicopters and stuff. So we want to do something where we could put up a camera on this or one of these devices and give it a GPS location to go to. It goes there, sorry, takes a picture and comes back. The main project that we are doing right now is using it as a UAV device, unmanned aerial vehicle. And in that what we're doing is we bought a Parrot AR drone 2.0 that just came out last quarter. And we're implementing that same gyroscope, we're implementing the same accelerometer in there. We'll probably be tweaking it up a bit, but we'll add our GPS module onto it where we can command it to go to a certain location, take a picture and come back. Right now, the controller that it comes with, you can download an app on an Apple iPhone, or you can download an Android app, and you can control this using that cell phone. But we want to take that cell phone control out, and probably we want a computer to control it, where all you do is you enter a command, let it go to a location, take a picture, come back. The other stuff that we were looking at was the marketing and research of it. And the marketing part of it, first we thought it has a deep, bright future going in, because we are planning on we're not planning on any obstacle courses right now. So there are projects out there which are planning on obstacle courses. Our main project would just be adding the main GPS to it, where we'll just let it go and it comes back. The other approaches that we were going to use in this, we were looking at, we first started off with the Arduino Uno board, and we researched all that. After researching everything, we're looking at all the quad rotors that we can possibly buy from the market. And those quad rotors were a lot expensive. So we went on with the Drone 2.0 that includes the Cortex ARM Cortex A8 chip that's manufactured by TI and Satara in conjugation with ARM. And we'll be using that microcontroller to process our information through it. After processing all the information through the microcontroller, we'll possibly be looking at sending the GPS through a wireless signal, because conjugating the GPS right now that we're looking at, it's based on the Arduino platform. So it would be a pretty good integration for Arduino with the TI microcontroller. So the only way that we found out for this was through wireless communication. So we'll be building that up and send a wireless signal to the ARM Cortex board, where we'll plug in the GPS locations into it and let the user decide wherever they want to put it on the GPS, whichever GPS location they want to plug in. And the other thing that we were looking at right now, going on to the next semester, would be like if you have something of this sort in your house, putting up obstacle-free course, or maybe planning out for next semester would be like a motion sensor, and I'll be happy to take any more questions. Yes, sir.
Each one of you guys.
Yeah, starting off with from Thursday. Thursday was responsible for researching for the GPS unit. Simon was responsible for most of the camera part. Richardson was also responsible for GPS, but he was for this semester responsible for all the report write-ups and stuff. Mark was the main, he's a computer engineer, he's the only computer engineer amongst us. So he, along with Kinay, being a software as well as electrical engineer, these people were responsible for doing all the coding part of the project. And I'm looking up to mainly the microcontroller part of it. I researched right now whichever microcontroller we got to use and what are the other interfaces we could add onto it.
Did I understand you that you were developing all of your, basically your stabilization routines? You're actually controlling the aircraft yourself?
We're not controlling the aircraft ourselves. There's already the Air Drone 2.0 that comes out. It already has an accelerometer and a gyroscope into it. And those, that would be controlled by that, but we would be tweaking it up a bit just to see what would be the threshold where we can take it out. Right now, the gyroscope readings, it's precise between 6 degrees, either way, plus minus 6 degrees. And I'm not really sure about the accelerometer readings, like how much we can tweak those, finding out the actual direction. The other thing that we use it plus GPS location within a small distance, it usually doesn't change that much. But we'll probably be using a magnetometer along with it, because that gives us a proper direction as well as the proper location of everything.
Will you be using a filter?
Right now, we're researching on all that. It depends on how this device, first when we get it to flight, the first flight, how does it work? And rest will depend on cancellation of all the other things. But we're not looking into any other wind factors or anything as such right now.
You have initial design for this summer?
Yeah, we had the initial design ready. We got the device ready, we got everything ready, but while we were tweaking it up, one of us, by mistake, had one of the cables, the ribbon cables on, so it's not working right now, sorry about that. But the design right now would be the microcontroller unit by itself, which will be communicating with the GPS unit, and there will be settings in the back and forth. There will be a camera that's already onto the board, where you can control the camera from outside. You can take multiple pictures, or it also gives you a live video feed, whichever way you want to use it. It would be saving all the information as of now onto the USB port, either a flash card or whatever you want to put on it. But we'll be looking into, if we have more time doing it the next semester, we'll be looking at where we can make it available on the web, a real-time thing, where you don't have to wait till the quad order comes back and put it on your computer. Take the USB.
Do you have either a customer base or a set of performance metrics that you will show that you're achieving your design goals?
Our design goals right now,
Not
since
qualitative, quantitative.
quantitatively, since we did not go on with any specific customer, this was the design based on what we were thinking on guidance of Dr. Bhatia. This is basically just a device where we fly in open field right now, but we would definitely like to look to incorporate if there's something out there, just to see. Yeah.
You will have to define some type of quantitative performance metric that you have to
Yeah.
benchmark against in order to kind of finish off the design.
Right now, all the research that we got done, there was nothing out there that would let you fly without using without playing, just putting the commands in on the computer and flying it. But right now, basically, it will be the radius that we're looking at for this flight, or this thing, we're possibly around 450 feet right now. And the height of it varies on the location, but it varies on whatever other interference that you have around that area. But the maximum height that we're looking at is also around 400 feet.
Thank you very much.